We have here a pretty useful equation. Let me just zoom in a little bit. This helps us calculate the interest or the effects of interest when compounded over a certain schedule. And you can see over here I've written what these variables mean. Go ahead and pause the screen if you're not familiar with this by now. But what we're going to do is calculate about how much time is required until an investment, in this case, quadruples. So I'm going to go ahead and plug in all the information I know. I'm starting with $1,500. I have a rate of 7.4%, which we want to make sure is written the way I just did right there as a decimal. Okay, if you write that as a percent, you're going to be way off. I have 12 months in a year. That's how frequently this is compounding. And that appears twice in the equation. And now sometimes people get stuck on this point, like where's the number? What's A? Well, it doesn't tell us, but it does tell us that it quadruples. So from the quadrupling information, you should be able to figure out that A is going to be 4 times as big as what we started with, or in other words, 6,000. And now what's pretty nice is that we just divide by 1,500 as our first step, and look what we get. 4 equals some stuff. Now, that 4 is the quadrupling factor, so that's a useful thing to keep in mind. I didn't actually need to know $1,500 was my initial amount. You could cross that out and we would have solved this problem exactly the same, gotten the same answer. So keep that in mind. Keep going, and we're going to find that the inside of this parentheses is something like 1.0061666 with a bunch of 6's, and there's my equation. So now I have to figure out what t is. And the only way to do that, since the variable is in the exponent, we're going to need a logarithm to bring the variable out of the exponent, to bring it down. So I'm going to choose the natural log of each side. Got the ln on the left and the ln on the right. And it looks kind of ugly because these things often are. Okay, now we're going to have to remember the power rule and how this exponent is going to basically just get yoinked down in front of the logarithm like a little coefficient. So we keep the ln of 4 on the left, and on the right we have 12t times ln of 1.0061666 with as many decimals as you want. And now to isolate t, to get t by itself, we just need to divide by everything that's multiplied by t. So in other words, 12 and natural log of 1.0061666 on each side. So 12 natural log of 1.0061666. So you'll want to be careful with your parentheses. I'm being a little casual here as I write this. But you want to be careful with your parentheses and how you're typing this into a calculator. Otherwise, you're going to get this wrong. So make sure in your calculator, you have those parentheses clearly marked, like I just put right there. And when I put this in here, what I get is 18.79, which because this thing was written in years to begin with, that means 18.79 years, which is not unreasonable. I mean, we're talking about quadrupling an investment. That's a pretty good return, so you'll have to wait a little while.